All right, welcome everyone. Today we're going to be introducing the idea of parametric equations and parametric curves. So specifically, today we're going to see how to graph a parametric curve. And we're going to do this by taking our parametric equations, and we're going to see what these are. And we're going to use those equations to just plot individual points that are on our curve. And then we're going to connect the dots to actually get the curve. This is really what we're doing. Now, we are going to be introducing this parameter t. And so as we kind of draw out our curve, we'll also be able to use arrows to kind of indicate a direction. So we're going to indicate the direction that we trace our curve out as this parameter t increases. All right. So before we actually get into it, let's take a step back and just think about how we can describe curves in the plane. All right, so how can we do this? Well, probably up until this point, the way we've done it is primarily with functions. So we've done things like use gadgets like y equal to f of x, and the graph of this function is a curve in the plane. So what do these generally look like? We have our x-axis, we have our y-axis, and then we have our curve. Maybe it looks something like this, y equal to f of x. Now this is pretty good. Get a nice curve, but there's some restriction here. And the restriction for a function is that the curve has to pass the vertical line test. So there's kind of a restriction when we think about these types of curves. We can't just draw any squiggle that we want. Might not be a function. If we wanted to really get creative, we've sometimes seen functions like this where it's actually x as a function of y. So we might have y equal to f of x, so y is described as a function of x. Sometimes we have x described as a function of y, so x is equal to a function g of y. And what do these look like? Well, we still have our x and y axis. But now we might have something like and these types of curves, they don't pass the vertical line test necessarily, but they would have to pass the horizontal line test. All right, so we have, if we're using functions, and that's what these two are, these are really functions here. We're describing one variable as a function of the other. So these are really we're using functions here to relate y and x. So x and y are directly related to each other in each of these. And that's pretty good. The only issue then is we're kind of limited in the types of curves that we can sketch, that we can have. Because for it to be a function, if it's y equal to a function of x, it has to pass the vertical line test. So if we draw a vertical line in, it can only cross the curve once. We can't like double back and kind of squiggle all we want here. So we're kind of stuck. Same thing for if we have x as a function g of y. Here, it would have, for it to be a function, it would have to pass the horizontal line test. So what we're going to see in this lesson is it's kind of a third option, and that's parametric equations. And this in some way kind of uncouples x and y. So they're no longer directly related to each other. So we're going to be able to draw in a whole bunch of new types of curves that we wouldn't be able to with our kind of standard approach of just looking at these functions, where x and y are directly related to each other. So y is a function of x, or x as a function of y. So parametric equations are sort of like a new option to us that we're going to see. All right, so let's actually talk about what they are. Well, we're still going to be using functions, but now x and y are both functions of a third variable, and we're going to normally use variable t here. So x is going to be a function f of t, and y is going to be a function of t, g of t. And so these two equations here are called our parametric equations. And so the kind of the picture to have in our head when we're thinking of these parametric equations is that as this parameter t varies, the point x comma y, which is really described, the first coordinate here is described by this function f of t, and the second coordinate here, our y coordinate, is described by this other function g of t. We really want to think of this point as it kind of traces out the curve. And the curve that we get is called a parametric curve. And so, we might have something, so in our normal xy plane, we might get some kind of really interesting curve here that as it stands, this wouldn't pass the vertical line test or the horizontal line test. So we get these new types of curves that we're going to be able to investigate. And the way you want to kind of picture them, kind of just a few notes here, is that we normally think of this variable t as representing time. So that's kind of a key thing to think about. We have our geography here. We have our geometry, x and y, but then we've also introduced this third variable, t, and t represents time. So you want to think of this point xy. You want to think of it almost like a particle. So this particle is moving around the plane. And so what these parametric equations do is they describe the position of that particle at time t. So we have our parametric curve. And so you want to think of it like a particle that's moving around the plane, and here is our particle at time t. So the benefit of these parametric equations is that variables x and y, they're no longer directly related to each other. So x, they're kind of uncoupled a little bit. X is now a function of time, and y is a function of time. And so we're going to be able to get much more interesting types of curves here that we weren't able to get before. All right, so let's try an example. So let's sketch the curve with parametric equations x equal to t squared minus 2t and y equal to t plus 1. So we have one equation that describes our x position at time t. We have a second equation that describes our y position at time t. And so the idea is to sketch the curve, to sketch our parametric curve here, we're just going to look at a few different time values, see what the corresponding x and y values are, plot those points, and then connect the dots. So let's do a little table here. We're going to have our t. We're going to have our different time values here. And then we'll look at the different x and y values. And we're going to plug them into these two equations. And just to get an idea, we can plug in any t values that we want, as long as it's defined when we plug it in. But let's just go for some nice integer values here as a starting. So let's do -2, -1, 0, 1, 2, 3, 4. So these are different time values that we're just going to plug into our two equations, and we're going to see what our x position is and what our y position is at these different time values. So let's start with time 0. Start with an easy one. Let's plug 0 into our x equation here. So we get 0 squared minus 0, 2 times 0. We get x is equal to 0. All right. What about when we plug 0 into our y equation? What is our y value here? Well, our y value is going to be 0 plus 1, so it's going to be 1. So when we start to sketch our curve, we have our usual y and x axis here. And for time 0, we're going to identify the point 0, 1, and that we're going to plot it. So 0, 1 is right here. And this happens when time is 0. We're at that point at time 0. All right, so let's fill in the rest of this table here. So let's take -2, plug it in to our x equation. What do we get? We get -2 squared, so positive 4. Another -2 squared, so we get another positive 4. So we actually get 8 here. And then when we plug -2 into our y equation, we get -1. So let's plot that point on our curve. So our x coordinate is 8, and then our y coordinate is -1. So at t equal to -2, we're right at this point. All right, now let's try plugging in t equal to -1. Plug it into both of these equations, see what x value you get, see what y value you get. So we plug -1 in here, we get -1 squared, so positive 1, and then a positive 2, so we get 3. And then our y value, we get -1 plus 1, so we get 0. So let's plot that point on our curve. We're at point 3, 0. And this is at -1. And I want to move my label here, because our curve's actually going to go through there. All right, so we've plotted a few points here. Let's just keep going down the line here and just plugging and plotting. So t is 1. What do we get? We get 1 minus 2. We get -1 for x. We get 1 plus 1. We get 2 for y. So plot the point. X coordinate -1, y coordinate positive 2. So we're at this point when time is equal to 1. Okay, keep going. Plug 2 in. We get 4 minus 4 here, so we get 0 for x, and then we get 2 plus 1. We get 3 for y. Plot it right here. Here we go. We're at that point at t equals 2. And let's do a few more. So 3, what do we get? We get 3 and 4. So that means we're at what point here? We're right around here. So here's when t is equal to 3. And then let's get one more point going. And that is, what is it? We get plug 4 in. We get 16 minus 8. So we get 8 for our x coordinate. And then we plug 4 into our y equation here. We get 4 plus 1, so we get 5. So our y coordinate here is 5. So we're going to plot the point 8, 5. And we're at this point when time is 4. All right. So we've connected, or we've plotted all of our points, and now we're just going to connect them kind of in order of increasing time. So let's see how we do this. Hey, not too bad. And One other thing we can do with these parametric curves is we want to think of it like this is almost like the movie of a particle that's moving in the xy plane. So almost exactly how we drew it out. If we kind of keep track of where we are when where your pen tip is when you're drawing this out, that's like the particle that's moving around here. And so we kind of have when we have these parametric curves, there's kind of two pieces of information that we have. We sort of have the geometry, so where we actually are on this curve, but then we also have that time. So we also have where, or what point we are, what point we're at, and specifically at what time. So there's a where and a when component for these parametric curves. So with that, we can specify the direction of increasing time. So we have our collection of points. So think of the actual curve as our collection of points, but then we're walking along that, curve, so there's a direction to it. And we can see that as t increases, we're going to follow along this curve and we're going to go in this direction. So we're just going to indicate this with arrows. So as t increases, we're tracing out this curve in this direction. And again, think of it like a particle that's just moving around in the xy plane. We have our location, but then we also have information about when we're at that location. So think where and when. So parametric curves, they give you the where, but they also give you a when. All right. So that's really how we do it. That's how we sketch a parametric curve. Take some different t values, plug them in, plot the points, connect the dots. Now, one other thing to note here is we have our parametric curve. So here it is. This was our parametric curve that we sketched. So this was our parametric curve. And really what this does is it is giving us, just like we said, it gives us the location where we are on the XY plane, but it also has some kind of information about when we're at each of those points kind of embedded in it. Now, if we think about just the x equation here, that also has its own graph. So, we might have the graph of our x function, t squared minus 2t. And so if we're thinking about just the graph of this function, now this is just a regular function that we've seen before. So, but now t is our kind of our independent variable, so that goes on the horizontal axis, and x depends on time. So x is going to be our vertical axis here. And so we could graph this function just like it's a graph of a function. So things we've done before. And this is the graph of t squared minus 2t. So we can kind of graph this function, and we could do the same thing for our y equation. So we could do that. Graph of y equal to t plus 1. Now here, time is the independent variable, so that goes on the horizontal axis. Y depends on time, so y is equal to time. So depending on what t is, the value for y is going to change. So y goes on the vertical axis. And so we have the graph of t plus 1, just a line here. And so the way we can interpret these two graphs is they kind of in some way they kind of fit together to form our parametric curve. And so the way we would read these two graphs is we can just use them to help identify the x value at a specific time and the corresponding y value at a specific time. So for instance, when t is equal to -2, we can look at our x graph here, read up until we see the point that's on the curve, find the point on the curve, and that tells us our x value. So the x value is 8. Do the same thing for our y graph. Find t equals -2 on the horizontal axis. Read up or down until you see the corresponding point on the graph. So we see it right here. And read over to find what the corresponding y value is. So y is equal to -1. And so by reading these two graphs, we know the point 8, -1 is on the curve. And you can do that for other ones as well. So if you wanted to, you could do t equals 1, and you'd see that the x value is -1, and then at t equals 1, the y value is 2. So we get the x value is -1, and the y value is 2. So we're just reading each of these graphs to get the corresponding x and y values, and putting that together, we see that -1, 2 is on the curve. And this is, this isn't anything surprising. If we go back to what we sketched, -1, 2, yeah, it actually was on the curve. Or same thing, 8, -1, yeah, we sketched that point. We plugged in the values and calculated that directly. But if we had these graphs, we could also use these graphs to help us kind of plot out that parametric curve. All right, so this is really the idea behind parametric curves, is that we have two equations, x and y, x as a function of time, y as a function of time. And to actually see what the parametric curve looks like, we're just plugging in different t values into each of these and plotting the corresponding points. All right, let's look at one more kind of case here. And it's the same parametric equations that we looked at in example 1. So we're going to sketch the parametric curve with equations x equal to t squared minus 2t, y equal to t plus 1. So the same equations, but now there's this extra requirement that we're only plotting points where the t value is between 0 and 4. So there's some kind of extra requirement here. And so we can think of, when we have these intervals for time, we could think of the starting t value here as our initial point, or the starting point of our curve. And then we could think of the ending t value as giving us an ending point for our curve, or a terminal point. So we'll have an initial point, which is at t equal to 0. For this specific, and let's maybe generalize it. So when we have an interval for t that's between some numbers a and b, the initial point is given by the lower number. And when we plug that in, it would have coordinates f of a comma g of a. And then we have the upper limit here for t, the other end of our interval here, gives us a terminal or an ending point. So when we plug t equals b in, what point do we get? Well, we're going to get f of b comma g of b. Plug it into our two parametric equations. So at times we use this terminology when we kind of put some restriction on time, where time is between just two numbers here. There's going to be an initial point and we say a terminal or ending point. So what would this look like? Well, we would go through the same process, do our chart for t and x and y. But now we're only going to use values for t that are in between 0 and 4. So, before we started with -2, then we did -1. We're going to start with 0 and then just work our way up. And then we're going to end at 4. So 4 is where we go. And there's no, we're using integer values here just because it's easy to plug in and evaluate. But we could refine our sketch by, taking numbers that are in between 0 and 1 and taking numbers that are in between 1 and 2. So the more points you plot, the better your sketch will be, the more representative it'll be. But to keep our calculations easy, we're just going to be looking at these integer values. Yeah, but if you wanted to, 0.5, 1.5, 2.1 if you wanted to. All right, so what were the corresponding points here? Well, we saw when we plugged 0 in, we got 0, 1 for our y coordinate there, then -1, 2, 0, 3, just kind of repeating what we had, 3 and 4, and then 8 and 5. So this was just our table of values that we had in example 1. And so we're just plotting the points now, plotting these points. And so again, we're still going to kind of trace this curve out in increasing time. So we're going to start at the smallest time value and then just trace out our curve from there. Ooh, missed it. Better. And went too far. Try it again. There we go. My hand's covering it up as I'm trying to draw it. There we go. So we get something like that. So we have our initial point. This is where our parametric curve starts, and then our initial point, and then we have our terminal point, our ending point. So it's just giving us a section of the curve, essentially. And again, we can trace this out in increasing time. So there's some kind of direction here. So we have this particle, starts moving at our initial point, and then it moves along, and then it ends at our terminal point here. And maybe that's where we stop watching it. So we have this particle sitting in the xy plane, and then it just kind of traces out this curve. It's moving at time. And so at time 0, starts off right here. Then at time 1, it's here. Time 2, time 3, and time 4. So we just have this particle, starts moving, it moves around this curve. And so at time 3, it's right at this point, keeps going. And then at time 4, it's right here. And then that's where our interest kind of wanes. And we stop watching it at time 4. All right. So this is really the idea for parametric curves. Take some different t values, plug them in to the two equations, see what the x values are, see what the y values are, plot those points, connect the dots, and then just keep track of increasing time. So we have that kind of directionality here. All right. So in the upcoming lessons, we're going to see, well, we're going to work a little bit more with these equations. So to kind of get a little bit more practice working with these equations. But then we'll see how to do some calculus on these parametric curves. All right, so we'll see you then. All right, have a good one. Bye-bye.